Welcome to this on-demand workshop, Warm Up Students with Amazing Math Routines. I'm Megan from the Math Workshop. I'm so happy that you're here. I want to thank you for taking the time to take a deep dive into all things math routines, which honestly are one of our very favorite parts of math class that can be used with really preschool through college classes. Anybody can be engaged, all ages can be engaged in a math routine. So we're going to share 7 math routines with you during this workshop. Let's take care of a little housekeeping first. Within the email that you received that contained the link for this video, you should have also seen a note-taking guide, and this note-taking guide is going to go step by step through the 7 math routines, including an introduction area at the start of it if you want to take notes as we go along. Just know that's there for you. And this workshop is about 2 hours long. So feel free to do whatever works for you. If you want to watch it in chunks, if you want to come back and rewatch it, go for it. Whatever works for you again. And also, in that email that was sent to you with the link for this video, you should have also seen several math routines Google slide decks. So I haven't done the math, but I think it's well over 1,000 different slides for it could be a couple thousand. Again, I'd have to look at, it's a lot. So feel free to use as many work for your situation and your students. Have fun. Also in that email, you should have seen a certificate of completion for this workshop and a SurveyMonkey link for feedback. We love feedback. So if you have ideas for future on-demand workshops you would like to see, we would love to hear from you. Or if you have tips on how we could have made this one better or what you enjoyed about this one, we just love the feedback. All right, let me take a moment to introduce myself if we haven't met before. My name is Megan Brewer, and I'm the creator of the Math Workshop. We support a community of mathematicians who believe that learning math to the deepest levels is possible for everyone. At our core, we're committed to making sure mathematics learning is fun and engaging, accessible to all, while ensuring that the instruction centers on making sense of concepts. We provide the tools and resources for students of all ages. So little guys, pre-K, all the way up to adults, including hands-on manipulatives, visual aids that help unlock the connections and the relationships between mathematical concepts. We believe that learning through investigations provides a framework for developing essential problem solving and critical thinking skills while promoting a growth mindset. I'm a former elementary school teacher. I was a math coach at a Title I K through 6 school. I worked for a large school district in the curriculum office where I had a very interesting job. My job was to share research-based strategies with teachers in my district on how to provide instruction for our multilingual students so that they could have access to grade level mathematics. So not watering the math down because they were acquiring a second or a third language, but what are those scaffolds that we put in place so that all students have access to the content? I've also worked as an educational mathematics specialist consultant for several companies traveling the United States to teach teachers and district leaders and math coaches different math workshops and different content courses and coaching teachers and facilitating model lessons with students while teachers watched and all the awesome things that go along with that. I've also worked as a curriculum designer and editor But now my favorite current roles are teaching students in my own local community and supporting educators and parents and students really around the world virtually. So I currently live in North Carolina. I'm the mom of two teenagers and I have a lot of fur babies. I love to travel and I am a voracious reader. So thanks for letting me share about myself. Let's check out this agenda for this on-demand workshop. As I mentioned, we will be exploring 7 math routines, and here they are. And again, your note-taking guide goes in this order. Quick images, which does not belong, array images, visual patterns, counting around the room, same and different, and tell me all you can. I'm curious, are some of these familiar to you? Are some of these new for you? And I'd be curious when I give tips of facilitation if you have facilitated them in a different way or a similar way. So the first video we're going to watch in a moment is going to contain an introduction for all math routines, as well as tips for facilitations of math routines. But then we're going to get into the specifics around the math routines of quick images, which does not belong, and array images, as well as visual patterns. So sit back and relax, and let's watch our first video. In this math workshop, we will examine math routines as a key tool in our math toolbox of strategies to support our students. We will share what they are, why we should facilitate them, when to facilitate them, where and how. Whether you are an educator new to teaching math, a homeschool parent teaching your young mathematician, or a parent interested in supporting your child, or an experienced math teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. What are math routines? Math routines are a daily 5 to 15-minute routine. They are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency. The teacher's role is to provide the math routine and to facilitate the discussion. Teachers do a lot of listening and learning about their students' mathematical understanding. The student's role in math routines is to think, reason, share, and learn from each other. They're honestly our favorite part of math class. This comes from educators, students, and myself. What are some math routines? Well, just to name a few, number talks, subitizing, quick images, which doesn't belong, tell me all you can, visual patterns, array images, same and different, guess the rule, and share your solution. And there's more, but those are just to name some. When should a teacher add math routines to their schedule? Math routines are a great way to warm up students' mathematical brains at the beginning of math class. They're naturally a great transition because students love to engage in them. I remember a first grade classroom that I was coaching in a while back, and the first grade teacher had students meet at the rug right after recess or break for their math routine time. And I was just so impressed with how eager the students were to get back inside, get settled quietly on the rug. They were so excited to participate in their math routine. Conversely, math routines can also be implemented at the conclusion of math class as an exit ticket. Students could record their responses in a math journal, on a post-it note, on a note card, on an individual whiteboard, or simply do a turn and talk with a partner. Maybe there's an odd 10 minutes in your class schedule for the day in between specials or subjects where a math routine would be perfect. Honestly, there's no wrong time to engage your students in a 5 to 15-minute math routine. Parents even love to see math routines modeled with them themselves at back-to-school nights. Where to engage your students with math routines? The answer lies in your particular situation and space. Educators take their physical space, their classroom, into consideration, whether they're gifted to have a large whiteboard projector, and if they have a rug where students can meet as a mathematical community, knowing they're just going to be there 5 to 15 minutes. So it's not too long, short and sweet. Additionally, teachers may want to consider what math tools would be valuable to be posted near that area, wherever they're going to have, where they're going to facilitate their math routine. For example, in kindergarten, I've seen teachers, of course, kindergarten teachers always have a rug. They'll have a large number path posted easily within view of the kindergartner's eyes to support their time in the math routine. Also, in second grade classrooms, I've seen teachers post a large 100 chart nearby the area where the students were engaged in math routines. So I know teachers just consider what visual representations or models might support my students' thinking and being successful during this math routine. Educators want to consider how where they facilitate the math routine impacts their students' ability for communication. Because we really want to foster students' thinking and as they're sharing with their classmates and listening to their classmates. So sometimes teachers don't want their students back at their desks where they're more spread out and where they're more likely to fiddle with things inside their desk and not give their full attention to the discussion that's taking place during the math routine. But honestly, teachers really have to think about their space and what works best. How to facilitate math routines. Well, there are nuances within particular math routines. We have more math workshop videos on the various math routines that we have on our website, themathworkshop.net. So, for example, with quick images, which are in essence a type of number talk, we only show the image to students for about 3 seconds, and then we hide the image. And the reason for this is because we're trying to gently influence our students not to count the items on the screen, but to see the groups of items. This is called subitizing. Each math routine has its own slight nuance, but in a nutshell, all math routines should be short and sweet. They should happen daily. That's why they're powerful, because the benefits collect over time for students and their understanding. And now let's look at some examples of some of the math routines that we can provide for our students. This is an example of a quick image. So you see dots. Students would be shown these dots for about 3 seconds. So you're seeing them for a lot longer. And they would be asked to consider 2 questions. First, how many do you see? And then, how did you see them? And again, we have more math workshop videos that dig deeper into each math routine, but this is just an overview. So some students might say, I saw 4 and 4 more, and I knew that made 8. So the teacher is the one doing the recording, listening to students, and the teacher might ask, who else saw it that way? And sometimes teachers teach their students the sign language, which means me also or me too. Essentially, I saw it that way too. It's a quiet way, for a nonverbal way, that the teacher can look around and see who else saw the 4 and 4. But then the teacher asks a wonderful follow-up question. Who saw it another way? I love that question because it's really a positive supposition that there are other ways to decompose this 8. So by asking it as who saw it another way, it's really inviting students to go, oh, there must be other ways. So then maybe another student might say, oh, I saw 2 and 2 and 2 and 2, and that makes 8. And again, the teacher is the one who's quickly recording, possibly, if the teacher makes that decision. Probably an early beginning of kindergarten, teacher might not be recording yet. They're just warming up the kids, getting used to this routine. Definitely later in kindergarten, the teacher's going to be recording these, the groupings and recording with equations and the numbers. And upper grades are probably more, they should be doing that too. And again, the teacher's going to say who saw it that way, and other kids might be doing the silent sign language for me too that you would teach the class. And again, the teacher's going to ask that follow-up question, who saw it another way? Or even if no one says they saw it another way, you could say, push them and say, can you push yourself right now to see it another way? And still some other students might say, well, I knew it was 8 because 1 and 1 make 2, and 3 and 3 make 6, and 2 and 6 make 8. And depending on the age of the students, again, teacher may want to record that corresponding equation and name the strategy. So that student was adding by doubles. So by naming the strategies, we can empower our students to now have this common language, because 1 and 1 make 2, 3 and 3, 6, those are doubles. And knowing the names of strategies can be really powerful for students to be able to make connections with each other and be able to use that strategy again. So the superpower of quick images, and quick images honestly can be used K through adulthood. The superpower of quick images is that students are seeing all the ways that a number, and in this example, it was 8, can be decomposed or broken apart. And on this slide, we're seeing 3 examples from students, and there are others, but we're looking at 3 examples. And this is a very important idea, that this subitizing, where students are seeing groups within a larger number, what sets make up that number, can make up that number. This actually begins to lay the foundation for success later in algebra. Now, it's really important that the dots, for using dot images for our quick images, that they're very strategically placed in purposeful ways. And there are resources out there for you on what dot arrangements seem to elicit groupings. So we do have more information on our website about this. So I would encourage you to explore that if these dot images, these quick images, are new to you. Let's look at another math routine. This one's called Which Does Not Belong. And in this math routine, the teacher usually shares a collection of 4 items. It could be numbers, shapes, photos, or pictures, sometimes words, and asks the students which does not belong, and asks the students to think about why. Why does it not belong? So here's an example of a which does not belong. It would be appropriate for kindergarten, maybe first graders who need to revisit some early numeracy work, or, let's be honest, there's going to be other students in other grades that perhaps for a multitude of reasons, some foundational mathematical ideas were not in place, that this would be beneficial to continue to work on. I'm going to pause so you can consider, out of those 4 10 frames, which does not belong and why. Some students might say that the top left 10 frame doesn't belong because the 5 red counters spill over into the 2 rows. So we see 4 and 1. Whereas in all of the other examples, the 5 is in a consecutive row. Some other students might say that the bottom right example of the 10 frame is the one that doesn't belong because all of the red counters are on the bottom row. And for the other examples, mostly the red counters are on the top row. Both responses are acceptable. The beauty of all math routines is that the thinking and the reasoning comes from the students. If you don't get responses that you think are really digging that deep, revisit the image later, another week, another month, come back to it another time. This is not really a time for you to teach or to show your thinking, because honestly, I think we've seen as educators that doesn't stick with kids. So revisit this another time, and maybe your kids are further along in their thinking, and then they might see what you were hoping in your mind they would see. In a lot of examples of which does not belong from various educational resources, you're going to see an A, B, C, D labeling. We intentionally did not label our collection of which does not belong because we strategically wanted students using positional words, which are in the kindergarten math standards, next to, above, below. So we want to give students that opportunity to use that kind of language. So they might say the top left, the top row, the bottom right, and so on. Here's another example of the math routine which does not belong. Which one do you think doesn't belong? Did I give you enough time? These are pattern blocks. And as a side note, you're probably going to want to have, I would say, really for all, I would say K through 6 should have pattern blocks because they're foundational for kindergarten, first grade, second grade, for shapes, talking about different characteristics and attributes of shapes, but also fourth, fifth, and sixth grade can use pattern blocks to work with fractions. And if you watch our videos that we have on our website or on our YouTube channel, we have a math tools video for fourth, fifth, and sixth grade that touches on this. So which one did you think didn't belong? Oh, and one more side note is the graphics that I'm using on this slide, you can access for free on the Math Learning Center website. They have interactive tools, which are a great way to model the tools, these manipulatives you would have in your classroom. All right, let's get to the answers. So some students might say that the yellow hexagon on the bottom right corner doesn't belong because all of the other options are either a trapezoid, the red shape is a trapezoid, or they're making a trapezoid. The shapes are composed together to make a trapezoid. Other students might say that the green triangle and the blue rhombus in the top right doesn't belong because it's the only option that has 2 colors, whereas the other options just have 1 color represented. Both answers are completely appropriate, and students would be using reasoning to come to those conclusions, and there could be more answers. Those are just 2. Here's a 6th grade example for which does not belong. In this example, the pinkish purple rectangular array is the only choice that doesn't represent 9. The superpower of the which does not belong math routine is that the options we present to our students should have multiple answers. They don't always work out that way, but most often they do. And that's really the beauty of it. So that takes thoughtful consideration on our part to design problems where there's multiple opportunities for reasoning. Next up is array images. With this math routine, the students will be shown an image and asked to consider some questions. The teacher should consider if math tools like manipulatives or grid paper, maybe individual whiteboards, would that be supportive to students' thinking and exploration during this math routine? And it's going to depend on the image each time. Depending on the time frame, the teacher will also adjust the number of questions explored. They will invite students, either independently or with partners or in small groups, to generate equations that match images. And possibly, if there's time permitting, students could do a gallery walk, viewing different students' equations, or pass the paper to examine equations to compare the equations. The images in this routine, though, I wanted you to know, are not intended to be flashed like the quick images routine. So we're just going to look at them and keep them up and be comfortable with them and see them. With the array images math routine, we recommend educators use the look, think, talk strategy. And honestly, this can really be used throughout the day in the classroom with multiple situations. So look, show students an intriguing image and pose a mathematical question. Think, give students a chance to think. Talk, engage students in a discussion about the image and questions. Here are some array image questions that a teacher could consider. And again, it's based on the student's age, the image you're using, how much time you have. But here are some of the questions you could choose from. What do you notice and wonder? How many are there without counting? That's what we're really pushing to. Now, some students might be just comfortable at this point counting, so we don't make them feel bad or shame them for any reason for counting. But we want to gently try to highlight the strategies that come from students that don't involve counting. That's where we're going to hover and give a little more time and energy to, because again, it's related to the subitizing, seeing groups of within a larger group. We might ask, can you see it a different way? What equation would match the way you see it? Is there another equation that would match the way you see it? And here's even a bonus question. If a student presents an equation that another student didn't come up with, can you push yourself to see how their equation also matches the picture and how? So once you get in the swing of doing this math routine, you'll come up with other questions too as they relate to the image. Let's look at one of these images. Depending on the age of our students, we might ask, especially if this was kindergarten, first grade, second grade, we might start with, what do you notice? So really, we're just entering, base level. Everybody in the room can be engaged because every child is going to notice something. Hey, Miss Brewer, I noticed there are dogs. Oh, I think the dogs are sitting on stairs. So we just want every student to be initially, again, we're just starting baseline, engaged. So what do they notice? Then you might and we're going to do this pretty quickly. We're not going to spend a lot of time on the what do you notice. The follow-up question might be, what are you wondering? Is it one family that has all these dogs? Where do they sleep? How much do they eat? Okay, so just give them a little bit of time to have that natural curiosity. What are your wonderings? Then we might get to, how many do you see? How do you know that? And again, we're not flashing this image. We let them look at the image. What equation would match the way you see it? Some students might say, I see 8 steps with 2 dogs on each step. So 8 times 2 equals 16. Okay, that might be a 3rd grade class, 4th grade, 5th grade. Another student might say, I saw 2 dogs on each of the 8 steps. So 2 plus 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 2 equals 16. The teacher can write the corresponding equations, maybe on chart paper nearby, or if this is displayed on an interactive whiteboard where you have the ability to record equations, I would strongly recommend doing that. All right, let's look at another one. Here's another array image. The teacher might decide that providing individual whiteboards with dry erase pens might be beneficial for this example. So the teacher's going to pre-think, do my students, would they need something to have access to this problem? Students would probably notice that the top row has 4 rolled items, and each remaining row below that has +1, +1 more, +1 more. So essentially we end up with an equation that is 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. With this problem, students probably would benefit from some place to record their thinking. That's a lot of math to do, mental math in our head without keeping a record of it somehow. I'm not saying it couldn't be done, but it might. Having a place to record our thinking might really be beneficial and open up the range of students that are successful with this problem. A follow-up question could be asked if, again, depending on the age of the students and if we feel it's appropriate to challenge them that day. How many rolled items do you predict would be in the 10th row? Why? How did you figure it out? Here's another example of array images math routine. Notice the questions that could be presented for students to use with this image. So the superpower of the array images math routine is due to the nature of the questions, especially the first question on the slide, what do you notice and wonder? As I mentioned earlier, all students are going to be able to participate with that question, and it's going to initially get them engaged about the image. For this math workshop, let's examine one more math routine. Let's examine visual patterns. These are the visual pattern questions that teachers can choose to use. Some of them are similar to the last questions we just looked at. What do you notice? What do you wonder? What do you think you will see in the next step and why? That will make sense in a moment. Now that the next step is revealed, what do you think you will see next and why? How is the pattern changing? So let's look at it at an example. When using the visual patterns math routine, you will share with your students that they're going to be shown some steps in a pattern. Their job is to consider the questions that you choose to ask. So what do you notice? What do you wonder? And most importantly, the question we really want to hover around and have the most energy around is, what do you think you will see in the next step and why? We are looking at the first step in the pattern now. What do you think you will see in the next step and why? Here's the next step in the pattern. Does this represent what you predicted? What do you see happening from step 1 to step 2? How do you predict the pattern will grow for the third and final step? Here is the final step. Is this what you predicted? How has the pattern changed? Depending on the age of your students, they may be able to come up with a rule or statement on how the pattern is growing. You can challenge students to predict the next design. That would be the 4th step, or the 10th, or the 100th. So again, that's really age dependent design in this pattern. Here is the answer key. And in our examples that you can purchase from our website, we have the answer key for you for all of them. So in this growing pattern, step 1 has 4 blue squares, 1 purple square, and a total of 5 squares. Step 2 has 8 blue squares, 1 purple square, and 9 total squares. Step 3 has 12 blue squares, 1 purple square, and 13 total squares. So between the steps, we're seeing a +4, +4, +4. So the advanced rule for upper grade students would be, oh, sorry, I went too fast, 1 + 4n. Now, we do provide the answer key for you as the teacher, but I want you to hear me clearly. We're not suggesting you reveal the answers to the students. Again, the purpose of the math routine is to see what we get from students. So the answer key, it's not going to show up on a slide like this. I'm just doing this for this presentation. It will be in your notes that you will have, but it's just to help you facilitate the discussion if the discussion goes that way. Oh, Miss Brewer, I notice it's a +4 each time. And so you can have that information in the back of your head because you looked at the answer key, and you're going to be thinking about how am I going to record that? So maybe even drawing an arrow and doing +4, drawing an arrow +4. You, as the facilitator, you're going to be making those decisions on what should I record and how should I record it so that all my students in my class can get access into whichever student was sharing what they noticed. The awesome part about recording for students is that it really provides a link between that visual representation of the pattern and the abstract mathematics in the equation or in the table. And most students, honestly, are going to need that. Not all of your students, but it's really going to support most. I know I benefit from seeing the equations, the tables, matching what I see in the visual. It helps solidify my thinking. The visual pattern superpowers that are used in math help students develop a deeper understanding of mathematical concepts, build foundational skills, their problem solving, their reasoning. It's really laying the groundwork for algebraic thinking. We recommend that educators use talk moves as a facilitation strategy for promoting classroom discussions. These talk moves prove to be a game changer in promoting student agency. And I know the poster that is on display there says math talk moves, but here's a secret that you probably know. They can be used in any part of the day, any subject. So revoicing. Oh, so you're saying that you knew 4 plus 3 is 7 because you knew 3 plus 3 is 6, and you added one more. And it could be the teacher's revoicing, it could be another student's revoicing. Repeating is hands down my favorite. So here's how we recommend teachers use repeating. Not in a punitive way, which I have used this in teaching in a punitive way, and now I regret it. Johnny, can you repeat what Sally just shared? Oh, you can't because you weren't listening. Come on, Johnny. That's not how we recommend using repeating. Repeating is an invitation. Oh my goodness. Who heard Sergio's explanation of that visual pattern? Who heard it and can repeat it? Because that is worth repeating. And if no one heard, and we only use repeating when we think it's like a great idea, we do want to hover because we think, well, maybe a couple kids heard, but not everybody heard. So let's hover here for a minute. So then you say, Sergio, that was so awesome. Can you repeat that again? And then I'm going to ask again, I'm going to invite who heard what Sergio said and would like to repeat it. So I tell you what, our kids, they want to, most of them want to be talking. So if we're setting them up for success, hey, all you have to do is listen to Sergio, and then you can volunteer to repeat what he says. Then after that child, whoever you called on, repeated what Sergio said, you always go back to Sergio. Sergio, is that what you said? And, how did that kid do? And again, it's in a positive way. And because sometimes kids don't repeat what the child said, and Sergio can say, no, actually, this is what I said. And then you can give that child a second chance. Oh, okay. Can you repeat it now? So we're just really teaching kids there is value in listening to each other and to considering what each other says and being able to repeat it, to think about it. I honestly believe, and I bet you do too, students can learn probably more from each other than they can just from me, the teacher, because there's so many of them. So let's empower them with that technique. I love reasoning. That's the next talk move, and that's math routines are all about reasoning. do you agree with? Do you disagree with? Why? How did you see it? Why did you see it that way? Can you explain that? Adding on is a favorite too. Who heard what Christine said and can add on to it? I'm always surprised, even down in kindergarten, that students have something to say about what Christine just said. It's amazing, but I've got to remember to ask the question. Who heard what Joe said and would like to add on to that thinking? And of course, wait time, something all of us need to work on, me included, and our favorite turn and talk. To summarize, remember that math routines are structured, repeatable activities in mathematics classrooms that provide a framework for engaging students in thinking, reasoning, and communication. They offer a predictable structure that supports both teachers and students, promoting deeper mathematical understanding and student agency, things we want from our mathematicians. They're honestly our favorite part of math class. We hear that from educators and students. Our hope is that you found this Math Routines Math Workshop useful in supporting you as you guide your mathematicians through math routines. We find math routines to be not only fun, as we've mentioned several times, and engaging, but extremely helpful in providing opportunities for students to make sense of math concepts and develop deeper mathematical understanding. Again, laying that foundational groundwork for algebraic thinking. We have more information on our website that you see on the screen, themathworkshop.net, about these various math routines that you see on the screen and others that we didn't have time to touch on during this math workshop. So feel free to go to our website, locate the resources page, which is there's a snapshot on the screen of a smaller part of the resources page, and you'll find more information under math routines. There's more videos, there's examples. So thank you for joining us, and we hope you have a terrific school year. Thank you, if no one's told you today, thank you for what you're doing for our students. All right, I'm back. Hopefully you found that video about those 4 math routines helpful. Feel free to pause this video if you want to. It makes a difference. Whoops, sorry. If you want to take notes, because we're going to continue on. All right. Here we go. So our next video is about one of our favorite math routines that really can be used pre-K through adults. Counting around the room. We can use it with whole numbers, integers, decimals, fractions. So let's take a listen and a look. Counting around the room. Hello, welcome. It's Megan over at the Math Workshop. Today I am channeling Elsa from Frozen, thanks to my teenage daughter. We're going to look at another math routine. Our math routine that we're going to look at today is counting around the room. Have you heard of this one before? It is honestly one of our favorites. It's a math routine that can be used with kindergarten, really up through adults. So we could use this in high school as well. Let's take a look at it. So in the math routine, counting around the room, as mentioned, it's a math routine. So you could do it at the beginning of math class. You could wrap up math class with it. You want to keep it short and sweet, 5 to 15 minutes. Students are going to be counting aloud, one at a time. This reinforces number recognition, counting sequences, and mathematical concepts. It can be so easily adapted for, again, a kindergarten classroom up through high school. Students could be counting by ones, twos, threes, fours, fives, tens, 20s, 50s, 100s, whatever. So whole numbers. You could be tying it with multiplication, with multiples. We could be skip counting by sixes, by sevens. Students could be asked to count by fractions. Let's count by fourths. Let's count by sixths. Let's count by tenths. They could be counting by decimals. They could be counting by integers. And they could be counting forward or backward. So you can change the starting point for the counting sequence. So for example, if we count backwards starting at 100, and again, all of us in the room are going to say a number, what number do you think we'll land on? You're going to purposefully, oh, this part's so important. You're going to record what students say, the numbers they say, in a way that highlights the key patterns. So we have to think to ourselves first as educators, okay, how am I going to record this? Maybe on a piece of scratch paper before I even do the counting around the room with the students. I might just jot down different ways I could record it. And so I notice which way is going to highlight what the most, what I really want my kids to see. You can consider using manipulatives, especially for younger students, or possibly a number line or other tools. First, you're always going to ask your students to make a prediction, and we'll have a question slide in just a moment. You want to stop about halfway around the counting and pause and ask students if they want to adjust their estimate and why, or why not. And you do want to have students in some kind of a circle, whether it's seated on a rug or maybe seated in chairs, or they could be standing in a line or in a circle. So you really want them to be able to visually see how many counts this is going to be. It doesn't play out so well if students are seated at their desk. And again, this is a math routine, so it's going to be short and sweet. So you're not asking them to be seated in a circle on the rug or standing in a line for a really long time. It's short and sweet. What are the benefits of counting around the room? Well, it reinforces number sense. It enhances active learning, promotes collaboration, provides opportunities for discussion, and offers a fun way, an engaging way to learn. So here's the process. Okay, first, you're going to ask, and I recommend you post your question. So wherever you want to put it on your whiteboard, your interactive board, chart paper, wherever you're going to be doing your recording. And maybe your question might be like the example on the slide. If we count around the room, and what we mean by that is around our group, everyone's going to count once, by twos, and we're starting at 0. So you always need to share what are you going to count by and where are you starting. And you probably want to count forward the first couple times, let kids get used to it. But then you can spice it up and go backwards once they've kind of gotten the routine. And you're asking, what number do you think we will land on? So they're going to be making an estimate or a prediction. You're going to give students a gift of silence for individual think time. So probably going to be doing some calculating. You want to invite students to turn and talk with a partner, to share and to listen. And that is has a strategic purpose. You want to do that so students have a chance to check in with a partner first. And what they're probably doing is kind of seeing, was my guess reasonable? What is my partner thinking? Then after you allow students to share with a partner, you want to invite those students that are comfortable to share their predictions aloud. You want to record them near where you had your question. I wouldn't put names with it. That's really, it's not about like, let's remember who said what. This is just, let's just get a collection of the estimates. So for those of you that feel comfortable. And again, we don't need to have everybody's estimate unless they want to. And maybe what you could do to cut down the time on this, instead of writing 20 estimates on the board, is if a student says, well, my estimate is we're going to land on 20 or whatever, then you can just quickly say, oh, give me a thumbs up if that was, or whatever symbol you want. This is the me too symbol for I agree in sign language. You could use that or a thumbs up, whatever you want to say. if that was the number you were thinking too. And then you're just looking around to see who thought that number. Because you don't want to spend the whole time just recording their estimates. So then you want to have the first student begin counting. And you're going to be recording, so your students can't go too fast because you're going to be recording while they're counting. And I want you to stop about halfway. It doesn't have to be exactly, but just kind of eyeballing to yourself. Stop about halfway around the room, pause, and ask students if anyone wants to readjust or adjust their estimate and why. And if there are some students that are, yeah, Miss Brewer, I want to change my guess from this to that, you just gently cross it out and write their new estimate. Again, no big deal. And you might say, why? Why do you want to change it? Then you're going to continue on with the counting and the recording. And again, this is the biggest part of this routine. Decide beforehand the best way you think it is to record their numbers to highlight what you want students to notice. So let's look at an example of the class is counting around the room by tens, starting at 26. I'm going to show you an example right now. Oops, scratch that. It's my next slide. Sorry about that. So here are the questions to ask. We'll get to that in a moment. Sorry about that. Here are the questions to ask. And you could have these posted for yourself so you remember. These are the really good questions. What number do you predict we will land on and why? What number will the person say who is halfway around the circle? What might we do if we get stuck? This is an important one because you might have some tools around the room, like if you're in kindergarten, maybe there's a number path that students could look at, or if you're in third grade and maybe they're counting by multiples of 7, maybe you have a 100 chart or a multiplication table posted somewhere in the room. So you want to help those students out that might have a little bit of difficulty by just, preemptively, well, what could we do if we got stuck? And another good question, and this is a different question, where might we get stuck? Okay. Does anyone want to readjust their estimate? If so, why? Again, you ask that one in the middle of the routine. And here's another good one. Do you think we will say the number blank today? Why or why not? So for example, if we're counting around the room by ones and we're starting at 1, maybe it's a first grade class or kindergarten class, you might ask, do you think we're going to get to the number 100 today? And based on what your students tell you, yes or no, that's going to tell you a lot about where they are in their thinking about numbers and sequence. All right, now let's get to the one that I preemptively talked about. This class is counting around the room by tens, starting at 26. You see that? What is being highlighted in the skip counting pattern that shows up in the way the teacher is recording? Isn't it interesting how the 6s, because they're all lined up in the ones place, they're just jumping out at us, aren't they? And noticing in the tens column, it's just going up by 1 digit each time because our tens are going up plus 10, plus 10, but we're seeing in the tens place an increase of 1. So this teacher was strategically thinking, how am I going to record this to highlight what I want to be highlighted? Let's look at another example. So here's another example, and there's the question posted. If we want to count around the room by 2, starting at 0, where will we land? And you see the students' estimates again up in the corner. It's not a big deal. We just take a couple. And again, we just, maybe the first child said 50 and we just say, did anybody else think 50? Give me a me too symbol. And we're just quickly looking around. Again, we don't spend too much time there, but we do want our students thinking and they're starting to do some reasoning. So that's why we do the estimate. Then notice how we recorded counting around the room by twos? What do you notice? Are those ones popping out again? How you see the column of the two in the ones place, then the fours in the one place, then the sixes in the one place, and the eights in the one place. So that was looking down the columns. When we're looking across in the rows, do you see that 24680, 24680, 24680, and so on? And what are you seeing in the tens place? So again, just taking a few moments before you actually facilitate the math routine of counting around the room to think about, how shall I record this? And you give it a try. And, if you think later, oh, you know what would have been better to do it that way? It's okay. Try it another day and record it another way. It's not going to hurt the kids, but it's just that intentionality of thinking about beforehand, how could I record this to really highlight the patterns? Here's another example. If we count around the room by fourths, starting at 0, where will we land? So again, the estimates were up in the corner. Now this one's a little bit different. You probably noticed the example before we recorded across was the ordering. And of course, the students would have been watching the teacher do that. You're seeing the end effect. In this example that we're looking at now, the teacher recorded columns. And again, the students would have been watching. So what is highlighted based on how the teacher recorded counting by fourths? Did you notice that each column is 4/4? Each column is 4/4. Did you notice that? So that was intentional. Did you notice that some students said the number as a mixed number and others did not? And that will really happen. So for example, up here where it says 5/4, that child could have said 1 1/4, but they chose to say 5/4. Both are correct. For example, down in the first column, the last number, that child said 1. That child could have said 4/4. They're both correct. So look at all the interesting patterns and observations and discussions we can have about our fourths. A teacher could also record these numbers on a long number line. I think that would be a fantastic tool as well. So I would spice it up because both recording it this way and on a number line are going to highlight different aspects, and they're both good. So the next time, maybe we're going to count by fifths, maybe I would do a long number line. So what if a student makes a mistake? Because it's going to happen, you know it. If a student makes a mistake while counting around the room, we believe it's so important to handle it constructively, to encourage learning, and to avoid discouraging the student. So mistakes are going to happen. It's okay. And we believe in the growth mindset, the research that cites that when we make mistakes, actually there's synapses and connections going on in our brain, and we're actually growing those connections and growing our brain. So we empower our students and share that information with them. There's nothing shameful about a mistake. So some tips. You could just record the incorrect number. Don't leave it there forever, but we pause and we allow a little bit of time for perhaps a student in the room to catch the mistake, because sometimes students will. maybe nobody catches the mistake. Then what could happen is then the numbering is going to get off because unless, you know, a student picks up on it. So it might be a time to pause. Don't only do this though, this technique I'm going to share with you. Don't only do it when students make mistakes because then their kids are going to pick up on this. But put in pauses even when things are going smoothly and just say something like, "Hey, let's pause for a minute. How's our list looking? Let's look over it with really discerning eyes. Let's be detectives for a minute. How's our list going?" And it's just kind of a time to check in. Give students an opportunity to find that mistake without, you know, calling out, "Hey, there's a mistake." Does that make sense? Um, because if we do leave it, then often the list is going to get really convoluted. So we could use that as a learning opportunity and have a convoluted list and leave it there and go, I think we should try this again. Let's see. And put the correct list next to it, you know, when they do it again, and hopefully maybe even change the order of the students so that there's a greater chance that that same mistake won't be made. Does that make sense? And then that can be a learning opportunity, have students compare the two lists and see, well, what happened? That's really problem solving. What happened? Let's compare our lists, compare and contrast. All right. So do be thinking about that. Sometimes that might happen. And, you know, there's nothing wrong with occasionally doing counting around the room in some small groups or differentiated groups, because if your class is like most classes, you know, the skill levels of where students are in their thinking today might be different than other students. So doing some small group counting around the room can really help for students that need it. All right. Well, we hope this math workshop video all about counting around the room was helpful to you in understanding this math routine and how it's beneficial to helping us learn about our students' mathematical thinking and in supporting our mathematicians to share and learn from each other. Feel free to check out more of our math routines. We have many on our website, themathworkshop.net, or on our YouTube channel. We're always updating the channel with new videos about all sorts of things from the mathematics classroom. We thank you for your support and your time. And if no one has told you this week, thank you for all that you do. All right, we are back together. Feel free to pause this video if you want to take some more notes on your note-taking guide as we're going to continue on. All right, here we go. Now we're going to explore the math routine of same and different. Have you used this one before? So sit back and relax. And as we check out same and different. Welcome to the Math Workshop. This is Megan. In this video, we will explore the math routine of same and different. This math routine can be used with students of all ages. And we've done the hard work for you. We've created over 200 different unique slides that you can use with your K through 6 students. We will share the link to learn more about where to purchase this awesome slide deck in the notes section for this video. These are the other math routines where we have done the hard work for you. We have hundreds and hundreds of colorful, engaging Google Slides with rich mathematical ideas to entice your mathematicians to further their thinking, along with free videos on how to facilitate each of these math routines. You can check them out at our website, themathworkshop.net, to learn more. So we have array images, quick images, visual patterns, tell me all you can, which does not belong, and this video, same and different. These are the other math routines that we will be adding to our math toolbox soon. number talks, so look for those, counting around the room, and guess the rule. So math routines promote student thinking, reasoning, and sense making. They strengthen your mathematical community and further students' understanding of math concepts, thus increasing their individual agency as confident, capable mathematicians. Here are tips for facilitating the math routine of same and different. You could use this math routine as a warm up or an exit ticket for math class. Just like all the other math routines that we've been sharing, you really want to keep it short and sweet. So you want to do it daily, really 5 to 10 minutes. So short and sweet. The role of the teacher is the same in all of these math routines. Our role is to ask, listen, and learn about our students and their thinking. You can use talk moves, which we'll look at on the next slide, to help facilitate the discussion amongst your students. Give students the gift of silence before taking any comments. Really honor that wait time. I know that we all process and think at different rates. I know that I can be a slow thinker, so it doesn't mean I'm not thinking good thoughts. It just means I need a little more time. So a lot of your students are going to be the same. And students could fill in a Venn diagram if you wanted to use along with this routine. So you'll see how that would help with the comparisons in just a minute when we get into it. Here are those talk moves that we love. I know the poster says math talk moves, but really we can use them throughout our day of facilitating discussions amongst our students. So that revoicing, and that can be from the teacher or from other students. That's oh, so you're saying that, blah, blah, blah. That repeating, I always remember that the repeating is an invitation, and it's an invitation to hover over a really interesting idea. So it's the teacher's choice. The teacher would say, oh, I'm thinking in my brain, oh, Jose shared a really cool thought. So I might throw in a who heard what Jose said and can repeat it. So it's an invitation. And if no one heard what Jose said, and sometimes that happens, I'll say, oh, Jose, that was just really interesting. Can you repeat that? And then let me ask again who heard it. And then usually there's always lots of hands that go up because usually most classes have students that want to talk and want to share. But then the other second part of repeating is I always want to go back to that first student and say, is that what you said? Once that other kid repeated, because sometimes students don't repeat what the child said. And the purpose of repeating is to hear that idea again. So I help model with students that if the student said something different, and I say, oh, and Jose might have said, no, that's not what I said, Mrs. Brewer, I said this. And so we give that other child another shot. So it's not a punitive thing. It's just trying to really implement that mathematical habit of really listening to each other, because I believe my students can learn a lot, probably more from each other than just from me, the one teacher. So I'm using these kinds of talk moves to facilitate that to happen. Then there's reasoning. That could be, do you agree with, do you disagree with? Also, reasoning could be, how do you know, why? Then there's that adding on. I love that one. I try to remember to do that. And it's so cool how, again, if a student shares something really intriguing, all you have to throw in as the teacher is, ooh, who can add on to that? And it always blows my mind from sixth graders down to kindergartners that often students have something they're like, oh, I would like to add on this. It's really cool. Then, of course, that wait time after we ask a question, allowing think time. And I always try to set my kids up for success and say, well, I'm going to ask a question in just a moment, but I want you to keep your thoughts in your head. And maybe I'll do some signal like, this means I'm thinking or something. And then I'll let them know, okay, now let's start our discussion. Because and again, I explain to students there's nothing wrong with telling them we all think at different speeds for different questions. So, it's not all that we're all going to be thinking along the same way, same rate. So let's honor um, all of our think times for each question. And then that great turn and talk, that elbow partner or shoulder partner, sharing. So first you got to have time to think, that gift of silence, but then you can do a turn and talk once I've had a little time to think about what I should say when we turn and talk. That's such a great facilitation strategy. So look at all the content that we covered in our same and different Google Slides. We covered number and operations with base 10. We covered number and operations with fractions and decimals, geometry, measurement, data, and statistics. And remember, this was K through 6. So that's why we have over 200 slides. And we divided up our slides into categories. So first we have models, then we have numbers, and then we have equations. And we really recommend you start with models because those are pictures and they tend to really open up the mathematics for all students. Models tend to really be presented in that conceptual understanding and supporting conceptual understanding, whereas numbers and equations are more abstract. So it just really, the models can lay a foundation to bridge that conceptual learning with the procedural understanding, which is numbers and equations. All right, so let's look at some of the models. And I want you to know that in the models, we put mostly kindergarten examples first, and then first grade, second grade, and so on. And it just kind of moves up through the content up to sixth grade. But I want you to know you can feel free, no matter what grade you're teaching, to jump in anywhere. And that's why we're not putting out there like, here's same and different routines for kindergarten, or here's another package for third grade. We're putting them all together. So you can differentiate. If you have days where you're able to take a small guided math group, and maybe these are some kids that would benefit from some thinking that was in some previous years' standards in mathematics, use some of the slides that would support their thinking there. If you've got a group of students that are ready to be challenged and ready to explore some mathematics that's maybe coming up in the next year, move up in your slides. Feel free to move around. So that's why I wanted you to understand how we scaffolded the examples. So the questions are always going to stay the same. The questions are really simple and they're in the name, same and different. What's the same and what's different? That's all we're asking, but they're so open-ended. They're really amazing. So I want you to know the first couple examples I'm going to show you right now really don't have anything to do with math. And the reason is purposeful, that we wanted. Welcome to the Math Workshop. This is Megan. In this video, we will explore, and then we have equations. And we really recommend, here's same and different routines for kindergarten, or here's another package for third grade. We're putting them all together. Students that are ready to be challenged. Welcome to the Math Workshop. This is Megan. In this video, we will explore the math routine of same and different. Routines for kindergarten, or here's another package for third grade. We're putting them all together. So you can differentiate. If you have days where you're able to take a small guided math group, and maybe these are some kids that would benefit from some thinking that was in some previous years' standards in mathematics, use some of the slides that would support their thinking there. If you've got a group of students that are ready to be challenged and ready to explore some mathematics that's maybe coming up in the next year, move up in your slides. Feel free to move around. So that's why I wanted you to understand how we scaffolded the examples. So the questions are always going to stay the same. The questions are really simple and they're in the name, same and different. What's the same and what's different? That's all we're asking, but they're so open-ended. They're really amazing. So I want you to know the first couple examples I'm going to show you right now really don't have anything to do with math. And the reason is purposeful, that we wanted students just to get familiar with this routine first before putting in the math content. So feel free, these are images I think that I've worked with K through 6th grade. I think all kids are going to like the images and they're appropriate for all. So I just wanted you to know that. They look a little different than the math examples. So here's one. And this is a non-math example again. You simply display the image, ask kids to have the gift of silence and considering what is the same about these two pictures and what's different. And this is not a teaching moment, honestly. We have the rest of math class that there might be teaching moments. This is really to see what do we get from our students. We're really going to learn a lot. Remember, we're asking, we're listening, and we're learning. So some examples of what students might say. Oh, these are both animals. That's something that's the same. These are pets. That's the same. They're both outside. That's the same. Well, what's different? One of the animals has its mouth open. What's different? They're different animals. One's a cat and one's a dog. So, we're just kind of getting used to the routine, and there's lots of different possible solution or answers your students are going to give you. Here's another example, again, non-math. So, they're both for transportation. They both happen to be yellow. They both have wheels. What's different? Probably only one kid can fit on the bike, maybe two. They really squeezed. I don't know, that might not be safe. The bus obviously can hold more, so your kids are going to come up with different things that they're going to tell you. Again, this is a non-math example. Here's another one. They're both balls. One, they're going to come up with different things. One's for dribbling, one's for shooting, one you use your foot, maybe your head, one you're using your hands. The other one you're not supposed to use your hands, I guess, unless you're the goalie. So again, a non-example. Here's another non-math example. All right, and I had one more. We have one more in here. Okay, now, so those were just to warm kids up. And remember, you're really going to want to just do one math routine a day because we're keeping it short and sweet. And if you're using that gift of silence and you're giving kids opportunity to turn and talk, and then maybe you briefly have a whole group discussion, then your time is past. Okay, so now let's get into the math examples. All right. So again, we're starting with kindergarten, and these are kindergarten math positional words that are in the standards. And so think about what those kindergartners might say about how above and below are the same and different. And again, there's nothing wrong with using this in other grades. Especially, you're going to see there's a lot of strong vocabulary support within these slides. So if you have students who have been struggling in mathematics, or maybe you have students that are English language learners and are acquiring a second or a third language of English, these slides can really be supportive. Let's look at another one. Still, we're in kindergarten, hoping that the students see the difference between solids and flats and how they're the same, how they're different. Here's another one with geometry. So there we have an example of a solid on the top and a flat shape on the bottom. And now look at the vocabulary. We've got the name for the students. You're not always going to see vocabulary, but sometimes you will. And also have some attributes with sides and vertices. Another one. Now we're really wanting kids to think about the difference between a side and a vertice. Well, it's the same. They're both attributes of shapes. What's different? It's different what they're looking at. Where is it, a corner? Is it the side of it? All right, now let's look at, we've got so many different models. Here's an example of using a 10 frame and a 5 frame. What's the same about them? Well, they're both filled. And again, if I was a teacher facilitating this, I wouldn't be sharing these thoughts. I'm just sharing them with you, that what students might tell us. So they're both filled frames. They both have 5 in a row. What's different? Obviously, the 10 frame has 2 sets of 5. All right. And we're also going to have some dot images, having students really think about the same and different. Some more 10 frame examples, but here we've got base 10 blocks on the top. So those are both representing 20, just for your information, but in different models. So we're having kids make connections. Then we've got the Rec and Rec tool. This is a hands-on tool that sometimes teachers get, especially kindergarten teachers, get a big class model set for demonstration purposes and then get small models for students to use. It has 20 beads if you're not familiar with it. And what's so wonderful about it, the colors don't matter. It doesn't have to be red and white, but it is important that you have 2 colors, whatever the 2 colors are. And the important part is that the 5 and the 5 on the left are the same color. So you can just visually, you just see that very clearly that that's 10, 5, and 5. And then the other set of beads are just a different color. So it's easy for that visual discrimination of decomposing numbers up to 20. Some more 10 framework. Here we're really wanting students to focus in on the missing part. That helps us to know how many there are by looking at what's missing. Here we have some really great examples of the 100 chart. So this is a 100 grid. It does not have the numbers in it intentionally. So it would be helpful for students to have some examples of having worked with a 100 chart or a 100 grid, but they don't have to. But you might want to, if you're going to use this slide, if they haven't had any examples, explain to them it is 100. They could probably figure it out. I know it's part of it's shaded. That's intentional because we want them to think about what's the shaded part. You can look at it either way. It doesn't matter, but you need to decide, do you want kids to focus on the shaded part or the unshaded part? This example is really easy because it's 50 and 50, shaded, unshaded, but other examples that you'll see in the slides are not half and half. So you just decide, which one do you want them to focus on and what's the same and what's different. So more vocabulary. We know in after kindergarten, there are standards in first and second grade about, it's actually beginning fraction standards, about students being able to cut up circles and rectangles in halves, thirds, and fourths. So we're getting ready to use that language and quarters as well. So you'll see slides that support that mathematics. Now, we also know in second grade, there's a standard related to it's getting ready for multiplication, and it's dealing with this vocabulary of columns and rows, and it's in relationship with arrays. So that in second grade, students are looking at repeated addition. It could be 5 plus 5 plus 5, 5 plus 5 plus 5 equals 15. And that is to build into what they're going to do in third grade, knowing that 3 sets of 5 is 15. So that you can hear how knowing the vocabulary of columns and rows can be really essential to understanding that array model. Here we've got those linking cubes. This slide is really, the purpose is to deal with even and odd numbers. That standard about students understanding that even numbers have partners or pairs, odd numbers do not. So seeing if students make that understanding, make that leap to it. You're also going to see a lot of examples with number lines. So first you'll see examples with whole numbers and number lines. Here we're counting by tens and counting by fives. You know, what is the same about these? What's different? They both start at 0. For these particular examples, they both end with 100. But of course, counting by fives, we see a lot more numbers than counting by tens. You're also going to see measurement standards. So here we are noticing a difference between an o'clock and a 30. You're also going to see within measurements some money work. So I really like these examples because the grid represents, it's got the number of units that are going to be in the cents. So for example, on this slide we're looking at, we have 25 and 25 for our quarters, and we have that 50 piece, that $50 piece, 50-cent piece. And it's showing, I love this because it's showing visually that 25 and 25 is the same, takes up the same area as 50. All right, so more money. Here's another, oh, still in measurement. We've got inches on the top and we have centimeters on the bottom. So we can have a discussion, facilitated discussion with students about what's the same. Those are both standard units that are used to measure, but they're different units. So we've got US customary on top, and of course we have metric on bottom. And here we have tools for measuring. So we've got measuring weight on the bottom, or mass, and on the top, temperature tool, thermometer. Got some patterns. We have that repeating pattern on the top. We have a growing pattern on the bottom. You're going to see place value work. You're going to see more number lines. This one has to do with greater than and less than. Modeling that. We're going to be using pattern blocks. This one could be, if students were ready, they could look at, this could be dealing with fractions. If they're not in fractions yet, they could simply see that they're both trapezoids. If they've used these pattern blocks, they know that the red one is just the trapezoid, but the green one, those are 3 green triangles that make up a trapezoid if you put them in that arrangement. We're going to have lots of different fraction representations and models because we know fractions can be so abstract, but when we can see a model, it can really support our thinking. So different, here we've got 1/5 and 2/10. They are equivalent, but that's hard to see because our wholes are different. So you can have a rich discussion there. Here we have 4/5 and 9/10, so they're both one part away from a whole. See if your students recognize that. If not, I'm sure they're going to recognize lots of other great things. Here we have the top fraction has one more than a whole, and the bottom fraction has one less than a whole. So you can see there's a lot of intentionality that went into all of our slides. Here we have that number line model for fractions, which shows up in grade 3. Very, very important. So we've got lots of different number line examples for fractions to support students' thinking. We even have negative numbers for those 6th graders. Here, some examples with the area model. There's 6 on both. We have 1 times 6 on the top is 6, and 2 times 3 is 6 on the bottom. Here we have an area model with items, cupcakes, and I think those are tomatoes. So what's the same, what's different? Here we have some square number examples. And here we have the number line and a word problem demonstrating multiplication. We're going to have some division work So there's a number line modeling a division problem. It's actually the same problem. And a word problem on the bottom that has to do with division. Here we have multiplication, but in two different ways. So an array and an area model. And the orientation is flipped. So on the top, we see, depending on how you look at it, but we could see 3 columns of 5. And on the bottom, if we're looking at the columns, we see 5 columns of 3. Here we have examples of area and perimeter on the bottom. So area on the top, those square units, and perimeter on the bottom. Here we have, I love this visual, distributive property for multiplication. So we've got the straight multiplication model on the left, and then we redistribute it to see the two groups within. So thinking about, what is this one? 3 times 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8. 3 columns of 8 is 24. That's for the first picture. And over here we have 3 columns first of 4 and 3 columns of 4. And that's 12 and 12, which is 24. We have some time interval work to think about. So the start time, the end time, and then we have this number line model showing how we can solve time interval problems. So what's the same about these examples? What's different? We've got these great vocabulary all up in 5th grade. About line segment, point, the different types of line, perpendicular, parallel. We've got some operating with fractions, got subtraction and addition, modeling it, what's the same. We hear you, Lily. That was the cat. Sorry about that. We've got greatest common factor, least common multiple, what's the same, what's different. So you can see how we're getting up into 6th grade, multiplying fraction by a whole number, dividing a fraction, and then multiplying a fraction by a whole number on the bottom too. I know we do have division ones too. We've got examples with mean, mode, median, and different types of data representations. Those words, reflection, rotation, translation, or different kinds of data. We've got our coordinates, their coordinate grid. Here we have multiplying fractions into the visual model. How are those two examples the same? How are they different? So here are the two factors in the fraction problem, and here's the product. And we're almost finished. I'll let you out in a minute. Here we have operating with negative numbers, integers, more of that. Here we have ratio and proportion problems and variables. All right. Whoa, that was a lot for models. So we're going to wrap up with numbers. You're going to see, again, we're going to start down in kindergarten. You're going to see, so we had whole numbers. There's a whole bunch of different whole numbers. You're also going to see fraction work. You're going to see decimals. You're going to see, again, those integers and exponents, square numbers. With equations, you're also going to see, again, we're going to start down in kindergarten and go up to 6th grade. You're going to see addition, subtraction, you're going to see multiplication, division with whole numbers, with fractions, with decimals, and with integers. Okay, so we made it through. That was a sampling of the over 200 slides we have in our slide deck. So hopefully that gives you an idea of what you could do with what's the same, what's different. Our hope is that you found this video helpful. Feel free to check out our website for other resources to support you and your mathematicians. And we thank you for your time, and we hope you have a great week. Thanks, everyone. All right, we're back. Is your head swimming with ideas? I'm curious, which of these math routines have you used in the past and which are new to you? Which ones are you most excited about using? We have one math routine left, and I'm guessing, if I was just a guessing person, I would guess this one might be a new one for you. I could be wrong though. This one is Tell Me All You Can. This one's very different, but when I learned about it, I really grew to like it a lot. So here's our last one, Tell Me All You Can. In this video from the math workshop, we will explore the math routine of Tell Me All You Can. This math routine can be used with mathematicians of all ages and levels, both big and little. Here are some ideas on how to facilitate this math routine. This math routine is very open-ended. There is an entry point for every student. You could use it as a warm-up when students enter math class, or you could use it at the end of math class as an exit ticket. It's really no right or wrong time. The point is not for students to provide the exact answer, but everything else they can think of about the problem or the image. Our job as educators is to ask, listen, and learn about our students' thinking. We recommend using talk moves to facilitate the discussion. Give students the gift of silence, that think time, before taking comments. Share and post examples with students, and I'm going to share some with you in just a moment. And a fun extension could be ask student pairs or trios to create a list of 4 tell me all you can statements, with one being a lie or one being false, for another group or pair of students to figure out. Here are the talk moves: revoicing, repeating, reasoning, adding on, wait time, turn and talk with your partner. These are the 3 categories for this math routine that are included in our Google slide deck, which you can purchase from our website for students in grades kindergarten through 6th grade. We have models, we have numbers, we have equations. We have over 300 examples. Let's look at some of them. Let's go into models first. So here's an example of a model, but there are also examples of possible student responses. We recommend that you share these student responses initially with students just so they get the idea of what is expected of them in this math routine. So some possible responses would be to this image of 8 dots. There's a full 5 row and there's 3 extra. There are 2 missing from the 10 frame. This is less than 10. I know that because a full 10 frame would have every square covered with a circle. There is more than 1. There are 2 sets of 3 and 2 more. Do you see those 2 sets of 3? It looks like the 6 pips on a dice and then the 2 extra. 1 more would equal 9. 1 less would equal 7. Notice in none of those statements says there are 8 dots. Because again, tell me all you can is really a math routine about beyond what the answer is. So students kind of have to get used to that idea. It's a different idea, but it tells us so much about their thinking. Let's look at another example again. This is a slide showing you what students might say, and this is for a 100 chart. And notice, or a 100 grid, notice there's a grayed out portion, okay? So students might say, and remember there's a really low bar entry point, everyone can say something about this image, all right? And tell me all you can. So here are some possible responses. There is a 100 grid with some shaded parts. There is a full 10 row shaded. There are 9 10 rows unshaded. There is more than one and less than 100 shaded. This is less than 50 because I can tell that less than half of the 100 are shaded. This is more than 5. So again, all of those are correct, but we can tell a lot about where students are in their thinking based on their statement. And we're not publicly evaluating their statements. It's all data that we're collecting, but we're facilitating this discussion and having students listen to each other. A recommendation would be for those statements that are really amazing, hover on those ones. Those are the ones where you'll want to say, oh, who heard what Jose just said and can repeat it? And if none of your students were listening at that time, say, Jose, that was so amazing. Can you repeat that? And I'm going to ask again, who heard it and can repeat it? So that repeating talk move is an invitation for students to listen to each other. And we only want to use it when it was really something you want to resonate around the room, that clear thinking that you think maybe when the child said it the first time, not everyone really heard it or really got it or really understood. So it's a time to pause and hover. Here's an example with a fraction model of possible student responses. There are 4 columns, some are shaded and some are not. There is 1 out of 4 shaded parts, or 1/4. Okay, that was an example where the answer came up. Sometimes students are going to do that. We just accept it, but we say, tell me more. This is less than half, and it's great if kids can tell you how they know that. This is more than 0/4. This is less than 4/4 because that would mean all of it would be shaded. And if you want to push students to tell you more, maybe they just say something like, this is less than half. You can say, tell me more. Or a talk move you can use is, who can add on to that thought? So now we're looking at a slide example that is without the possible student examples. So remember, those possible student examples were just to get your kids warmed up and thinking about what this routine is like. But normally you're just going to show a slide like this. We're in the models section, and it's just tell me all you can about this. And remember, you want to give your students think time, because not all of us are fast thinkers. I'm not. So I respect a little bit of quiet time to think before I'm asked to share. This would be a kindergarten example. But sometimes, of course, there are students in other grades that would benefit from kindergarten math standard examples. And so that's why we've included in our Google slide deck K through 6. So you can differentiate. You could do this with small groups in your room. So the deck is arranged within those 3 categories to get progressively more challenging. Here's an example using base 10 blocks. Here's another example with the 100 grid. Here's an example with fractions. I love this one. Students are asked to think about what the shaded region represents and tell me all you can about. Like right away, I can see, wow, this is definitely less than a half. Even though those two shaded regions or portions are not together, it's okay. I can be flexible in my thinking. My eyes can see it's definitely not going to represent a half. It's much smaller than a half. It's a little bit more than zero. A little bit. It's a small amount. Here's an example, we're still in our models, with a number line. Students are asked to focus on the location of the star. Again, tell me all you can about. This is a really good example because it's probably pretty hard for us to come up with a precise, exact answer when it's displayed up on a board and we're not using any tools for measurement. So we can really show our number sense here. And our students noticing where that first hash mark and what the number is there, which is strategically there to provide information for us, and what the other hash mark, what that number is. Here's another number line model example. What do you think students might share? On this one, we're focused on where is that smiley face? What point or hash mark or location on the number line do you think that represents? Now, I have to be honest with you. This number line, whenever I'm teaching courses or workshops for teachers, really bothers them. Do you know why? They don't like that there isn't a place for the one. But I'll tell you a hint. We have everything we need to know in this example. Don't tell your kids this. Let your kids figure this out on their own. But from the 0 to the 1/4 mark, that's a very important line segment, giving you information on the length of a fourth on this particular number line. So you have all the information you need to figure out roughly where that smiley face is presented. So I challenge you, don't always provide on a number line the 1. Don't always go from 0 to 1 for your students. They can be challenged. They can be flexible in their thinking. Take that 1 away, but give them enough information with that iteration of whatever the amount you want to be, that they could use that length to figure out approximately wherever the star is or the happy face or whatever little image you're using. Here's a 6th grade example in the models section again. And this one's with coordinates on a grid. And, maybe the 6th graders are going to tell you exactly the location of the dot. That's okay, but then push them. Tell me more about it. And hopefully they'll be talking about those positive and negative coordinates. So let's take a peek into the numbers section. That's another category in this math routine. Here's an example for kindergarten. Again, just for kids to kind of get their heads around what to do with this math routine. So if 1 was what was provided, some kindergartners might say, especially if they have a number path in their room or some models to help them, it's more than 0, it's less than 2, I have 1 nose, I have 1 cat, we have 1 teacher, I have 1 brother, my sister is 1 year old. So we know young students are going to make it very personal, and that's great, especially with number, because we want them making sense of number. So that's, again, just an example of all the possible, and I'm sure there's many more, but possible responses students could give. Oops, went a little too fast. Here's an example with fraction. So we'd present 2/6. And again, these are possible student responses. And again, we've got a really low entry point, but we can really learn from our students. And what I mean by that is students can tell us anything that they're noticing about what we're presenting. So students might even say, it's not on the slide, student might say it's a fraction. That's acceptable. Yes, it is. There's a 2 in the numerator. There's a 6 in the denominator. This fraction is equivalent to 1/3. I might ask that student, "Ooh, tell me more," or who can add on to that? Because we'd love to hear that because I know because this fraction is less than a half. Maybe a student says, I know this fraction is less than a half because a half would be 3/6. And this is 2/6, and that is 1 part less. Another student might say, I know this fraction is greater than 1/6 because this is 2 out of 6. So it's actually 1/6 more than 1/6. Another student might say, I know this fraction is less than 1 whole because I know 6/6 equals 1 whole, and this is just 2 out of the 6. Another student might say, this fraction can be decomposed into 1/6 and 1/6. Listen to all of that learning, and it comes from the students. This isn't us telling them what to say. It comes from the students, and they learn from each other. So again, using that repeating talk move strategy, you can really hover around the really interesting ones. Okay. Let's look at another example. So here's another example with decimal. Maybe the first student says, I notice it's a decimal number. Yes, it is. Oh, I have a typo on the slide I just noticed. I will fix that. It says there are 32 nines in this number. No, there's not 32 nines. So if that happened, if a student, and we know this happens, student says something that's not correct, I love to go ahead and record it and see who in the room might speak up and say, actually, Miss Brewer, I don't think that's right. Or maybe after they're all recorded, then I pause and say, I'm wondering, what do you think about all these? Let's evaluate these for a moment. And again, we're not making a big deal or making that particular child, we're not even going to say who said it. Not making them feel bad, but it's a moment of learning for all of us. So my typo is there's not 32 nines in the number. There's 2 nines in the number. It is 1/100th less than 1. There are 9/10ths in this number. There are 9/100ths in this number. You read this number as 99/100ths. This is less than 1. And again, if a student didn't provide more with that one, I might say, well, how do you know? What's the because? Or who can add on? Let's look at all those great responses. So the whole numbers go all the way up to millions, again, because we want to support in our slide deck, we're supporting kindergarten up to 6th grade. But it's not only just whole numbers. We have fractions, decimals, negative numbers too. And in the equation portion of our slide deck for Tell Me All You Can, let's look at some of the examples. So again, we're going to start off pretty low, kindergarten level. And here's a kindergarten, maybe grade 1 example. I mean, there might be some grade 2 students that would benefit from looking at this. So we've got 4 plus 4 on the screen. And again, this is possible student responses that we could share with students so they get their brain around. It's not just the answer. In fact, the answer is not even up there. It's other ways of thinking, pushing ourselves to tell me all you can about this equation. So here they are. It's more than 4 because one of the add-ins is 4. So it's got to be more than 4. So I'm showing that I understand that addition, that joining of our two add-ins. It's less than 10 because I know 5 plus 5 is 10. And this is 4 and 4. And I know 4 is less than 5, so it's got to be less than 10. The answer will be even because 4 and 4 are even. And I know when I add an even number and an even number, my two add-ins are all going to match up and result in an even number. Wow, that's awesome thinking. We would be so happy if we heard that from students. It's less than 10 because I have 5 fingers on each hand. So 2 hands would equal 10, but this isn't 5 and 5. This is 4 and 4. So it has to be less than 10. All right, look at that great thinking. We would be so happy to hear that from kindergartners. And some of these kinds of thoughts you are going to hear. Operations included in this deck for equations include addition, subtraction, multiplication, division with whole numbers, fractions, decimals, and negative numbers because we're taking it up to 6th grade. We hope that this math workshop video was helpful to you in understanding how powerful and fun and very open-ended, again, with that entry level, that's a pretty low entry level, but that can be taken up to the ceiling for our students to help us learn about their mathematical thinking and in supporting our young mathematicians to share and learn from each other. Again, it's not coming from the teacher. We're not telling them what to think about these models or numbers or equations. It's coming from them. And if you find that your students are struggling, just back up the numbers or the equations or the models you're using, and you can revisit and slowly build over time. You will be impressed with, I would really recommend starting with models. Those visuals really seem to really open up the mathematics for students before getting to the more abstract numbers and equations. Feel free to check out more of our math routines. We are building our library of videos and materials on the math routines daily because we just think they're such a powerful part of math class. So check them out as we're releasing them on our website, themathworkshop.net, or go to our YouTube channel where we have video examples for free we're building that library too all the time. But we thank you for your time today, and we hope you have a great rest of your week. All right, welcome back. How are you doing? Is your head still swimming? Okay, sorry, getting back into my PowerPoint. We're wrapping up with our 7 math routines. So we wanted to share as we wrap up that we have other additional on-demand math workshops that we wanted you to know about. We have kicking off workshops. So kicking off kindergarten math, kicking off 1st grade math, and so on up through 5th grade math at this time. You'll find those on our website. We also have, because there's so much to know about the math standards in each grade, we have a part 2 for kicking off math that we call Keeping It Going. So keeping it going, kindergarten math, and so on up through 5th grade at this point. We also have, now we haven't made this one yet, but it's on the books to make part 2 for math routines on number talks and procedural fluency math routines, which we haven't named yet, but thinking about what that could be called. So we also have a workshop on procedural fluency and conceptual understanding. What are they? How are they different? How are they the same? Which one should I teach first? How do I teach them? What tools will help me? We have rich task investigations. A good one, doesn't matter what curriculum you're using. This one's really going to help you become a discerning consumer of your curriculum and help you to choose the really rich problems that your students will get the most mathematical thinking out of. We've got a fractions and decimals boot camp workshop. We've got a great one, math strategies versus algorithms. How are they different? How are they the same? What's going on? How do we even understand the standards and what the standards are talking about when they talk about strategies or standard algorithm? And then we also have small groups, math centers, and games. And we're always open to adding to our on-demand. workshops. So you can shoot us an email if you think of a topic that you'd like us to make one on, or fill out that SurveyMonkey feedback and put there for us any feedback on future workshops. We wish you a terrific school year. And if no one has told you today, thank you for all you do.